Okay, so we're going to go ahead and get started with the 205 session about Netflix and our media transcoding transformation using the Amazon cloud. So my name is Kevin McEntee. I run the digital supply chain efforts for Netflix. We focus on working with the studio partners, the Hollywood studios and other studios that provide content to Netflix for streaming. So we work with them on getting their video assets, their audio assets, their artwork, their subtitles, taking all of that, transcoding it, packaging it up, and having it ready to stream to our 30 million Netflix customers. And really what this team is about is creating a great customer experience. We want customers to sit down and have a great experience when they're using Netflix video. We want it to look beautiful and sound beautiful. And we go through a lot to work on that with our studio partners using the Amazon cloud, and that's really what I'm here to talk about today. So I'm going to talk a bit about Matrix. Matrix is our Netflix media processing pipeline. Then I'll talk about what's coming next, or the next generation of the Matrix called Maple. And then I'll talk a bit about how I see an opportunity for content owners to use AWS, perhaps to build digital vaults for their own content. And then I'll have some concluding thoughts. But before I start, I'm just curious, are any folks in the room here from the studio industry or working on at Hollywood studios or sending content to Netflix? Okay, quite a few. That's good. Okay, good. So this is the basic high-level architecture of our Netflix media pipeline. The content starts out at the various movie studios. In this example, Walt Disney, or Disney Pictures, Warner Brothers, Lionsgate. And they deliver to us through industry standard networking protocol called Aspera. We worked with Aspera and Amazon to get Aspera implemented on EC2 so that as these studios wrote to us using Aspera through their standard tool set, those files went right into S3. And then we pick up those files out of S3, and then we process them with our fleet of EC2 instances. We run anywhere from a few thousand to 6,000 instances transcoding video at any one time. And currently, we're actually doing a very large transcode because we've selected a new H.264 video encoder for Netflix from a small startup in Palo Alto called IIO. And then so those encodes get written back into S3, and then we use FTP and other means to copy them out to the content delivery networks, including third-party networks like Akamai and then our own Netflix Open Connect CDN initiative as well. So this is the basic architecture of the Netflix media pipeline as it exists today. But to sort of set the context for how we got here, let me go back in time to 2008 and describe sort of how we got there. So to describe that, let me play a game here I call the Driving to Hollywood game. So this is a Google map that plots the route from Las Vegas here down to Hollywood. And if I had to put together a project to transport everybody in this room from Las Vegas to Hollywood, I could do it using either a fleet of Ferraris, which would be kind of fun. We'll get there quickly, or a few of us will get there quickly. Or we could do it with a fleet of Toyota Priuses, okay? And just to rig the game a little more, here's some of the rules. With the Ferraris, they can go 200 miles an hour. Any one of you could get there pretty quickly. But they're only available for purchase. And the quantities are limited, and they break down often, and you have to fix them when they break down. And then when you get to LA, you actually have to pay to park the Ferrari. And the Ferrari will be obsolete in about 1 year. Whereas the Priuses, at least in this game, they can go about 85 miles an hour at top speed, but you only have to lease them, and you can cancel that lease anytime. And there's an unlimited quantity of the Priuses available. And if it breaks, the lease company will replace it for no charge. And then you don't really have to park it. You could just pull up to the curb and walk away when you get to Hollywood. So with this kind of rigged game, I think you can kind of see the point I'm getting at. Is you could move this room to LA a lot faster with this fleet of Priuses than you could with a Ferrari. But why did I use Ferrari as the analogy? And it's really because of the heritage of the media processing industry. Back in 2006 and 2007, when Netflix was first beginning to experiment with streaming video, the sort of the state of the art for video processing technology was trying to optimize the experience that a video editor might have. So a video editor might be sitting down making a master or authoring a Blu-ray image of a particular movie. And all the technology you see in this edit bay was optimized to optimize for the expensive time of that one operator, essentially the artist sitting there doing that mastering work. And a lot of the technology around Hollywood for processing video sort of came out of this heritage. And the idea was to really optimize this one individual and really make the equipment run as fast as possible, really focus on latency for any one edit that you're doing. And that's where sort of the Ferrari analogy comes from. And back in 2006, 2007, we hired people out of this industry. And we ended up building out a data center that was very kind of Ferrari-like, or actually a few racks in our data center of some custom GPU encoders, boxes that had custom GPUs that we built specifically to encode video very fast. But it was expensive. There was kind of a fixed size, a fixed footprint we had available to us in that data center. And then come in fall of 2008, we found ourselves in a position where we had the opportunity to roll out a new PC player, a new Macintosh video player for Netflix, and then also our big jump onto televisions by launching the Netflix player on the Xbox. And there was such an amazing lack of standardization around video streaming in those days, and still is today, that we had to create new formats for those players, or one new format for those three players. And at the same time that we were innovating in the player space and therefore causing the need for new formats, our content team in LA was licensing more and more content. So our content library through the course of that project also doubled in size. And so we set out to re-encode using the hardware farm that we had built, our Ferrari hardware farm. And we had frequent hardware failures. The fans that we had on those custom SKUs were too small for the hot GPUs that we had, and the boxes were melting, and it was really a very frustrating experience. And in fact, that catalog re-encode was late, and we failed. I mean, basically, we launched these players, and the catalog was not complete. So we still had, for a few weeks, a user experience where for some of our catalog, customers would press play, and nothing would happen because the encodes weren't done yet. So this is pretty much a failure that we reflected upon. And if you jump forward a year, we had made the jump to move our transcoding farm into AWS. And we had a similar opportunity in the fall of 2009 for launching a video player on the PlayStation, the Sony PlayStation. And so this is our first sort of 100% AWS transcode. And the player developers, again, realized they had to rely on a new format. We had to retranscode the entire library again. And the actual final format wasn't really worked out till 3 or 4 weeks before the launch of the player. But that was okay because we were able to just spin up enough instances in EC2 to transcode the entire library in about 3 weeks. And so this is sort of the first time that we had rapidly set out to retranscode the entire library from start to finish and have it happen on time and have a much higher degree of control over that process. And so by moving to the cloud, while the latency of any one encode was slower, the overall throughput of the whole system was much, much higher. So that's where we ended up, and we're still in a very similar situation. It runs in US East. It's a variable size EC2 farm. We've had it as high as 6,000 or 6,500 instances at any one time transcoding video. We use S3 for the storage, actually S3 RRS for the storage. And it's optimized, like I said, really for throughput rather than latency. And we haven't really missed deadlines and things since then. And in fact, even more than just not missing deadlines and things, it's actually created opportunities for the business. And sort of my favorite story about the opportunities it's helped create is back in 2010, Apple approached us in February of 2010, mid-February, and said, hey, we've got this thing called the iPad. Everybody had heard the rumors and things, but they came to us and said, no, it's real, and we're going to launch it on April 10th. And we want Netflix to be part of the launch and have the Netflix player available at launch. And so, as you might have guessed, this platform required another new format for the Netflix library. And we grew the EC2 farm at that point to its high point, 4,000 instances, and transcoded the whole library in the final 2 weeks of that project. And then we were ready. We launched with Apple At their launch event, we had the entire library transcoded, and Netflix Player was available on day one when the iPad launched. And so this is an opportunity that we didn't anticipate when we set out to do the AWS project, but what we have found is that having this ability to scale the whole system quickly without doing any purchasing or building out of data centers ourselves really has made the business very nimble. And so you really can't put a price on nimble, especially in a business that's moving as fast as Netflix is. So again, the media pipeline, again, the story is, for Netflix, throughput trumps latency for our use case. And so it's very highly suited for the cloud. So we're thinking horizontal, not vertical for this use case. And so Priuses move a lot more people than Ferraris. And Netflix is nimble. So there's a few more examples of continued additional benefits that we've realized in the last few years. We've gotten into the game of launching Netflix in territories outside the US. So in 2010, we launched Netflix in Canada. In 2011, in 43 countries in Latin America. And then Great Britain and the 4 Nordic countries here in 2012. The Nordic countries was just a couple of weeks ago, actually. And every one of those launches required us to go out and work with the Hollywood studios to build up a new content catalog specific to that licensing territory. So again, a lot of transcoding of a lot of new content from the studios was required to hit those deadlines. And those were fixed deadlines. I mean, to do a territory launch, we have to align a tremendous amount of public relations and content deals and events and everything else. And it's not really an option to run out of time or to not hit that project. And in each case, we had the entire library ready at launch. So that's another way where our horizontal strategy is working out for us. And then I mentioned the customer experience and continuing to innovate with the video experience that our customers have. We've been able to do that too. Right now, we've selected a new H.264 encoder from IIO, and we're busy using EC2 to retranscode all of our catalogs around the world using the IIO transcoder. And we've begun to talk to companies that are developing sort of what's coming next, which is HEVC or H.265. And when that becomes viable and we start to see televisions and other things with HEVC decoders built into them, then I'm sure we'll undertake the effort to retranscode or transcode the library again for a new format for H.265. So this continues to pay off for us. So 5 regional catalogs. We support 4 formats today. So 1 legacy VC1 format and 3 different H.264 formats. And we encode multiple bit rates per format. So for every movie that we get or every TV episode that Netflix gets, we end up basically rendering it or transcoding it in our transcode farm about 40 or 50 times. And all of that has rolled up to several petabytes of storage in S3 today. So, clicker. Okay, let me talk about Maple, our next generation media pipeline. So our current architecture does have some limitations. Probably the biggest is that sometimes the high latency does cause some problems for us. If you take an HD source for, in this case, our show Lillehammer, and it comes to us in 80 or 100 megabit per second files, and then we transcode it down to one of our HD bit rates around 4 megabits per second. For any 1 2-hour movie, that can take 2 to 3 days on a EC2 C1 medium instance. And it's not really fault tolerant if we're running these transcodes for 1 movie for 2 or 3 days, because if 2.5 days into the transcode it fails, we have to start over from scratch and spend another 2 or 3 days transcoding that video. And the maintenance of our farm is challenging as well if we can't sort of take the instances up and down because it might be in the midst of a multi-day encode. And sometimes the business is coming up with more use cases where latency does start to matter. So sometimes we get opportunities to put a show up on our streaming service the day after it's broadcast. We're doing that with a few shows in Canada today, where we put it up the day after it's shown on broadcast television. Another example is redelivery of damaged content. Sometimes we have content up in front of customers from the studios, and we didn't realize it was damaged when they sent it to us. It slipped through our nets. and we need a redelivery from the studio. Maybe the audio and video are out of alignment, or the subtitles are out of alignment with the video. And so we will take a new delivery from the studio and retranscode it. But it's hard to sit on your hands sometimes when you know an encode or an experience is out there, it's a bad experience, and it takes us 3-4 days to do the transcode and get it up. So we would like to be able to address that more quickly. So what we're doing with our next generation is rather than encode the entire video, we're actually chopping up the video into 5-minute chunks. And then each of the 5-minute chunks ends up out on its own EC2 instance. And then once they're all done, we stitch them back together into one video, one contiguous video. And so by transcoding this way, we're able to achieve near real time. So a 2-hour movie should take 2 hours or less to transcode in this new environment. So it's running at the concept. It's running now, sort of in our test systems, and we'll be rolling it out slowly here in Q1 and Q2. And really, to address the only real drawback we've had by going with AWS is now we're able to have a very fast and low latency environment for doing our transcoding. So moving on to what I call the digital vaulting opportunity. Let me use an example to make the case here. So Dr. Zhivago was a great movie made in 1965. And in fact, in 1965, it won the Oscar for Best Cinematography. It was a beautifully filmed movie. And it came in a nice widescreen aspect ratio, 2.2 to 1. But the owner of this movie over the years has had to make several different prints for several different use cases, since 1965. They put it in theaters. They reformatted it for old 4x3 televisions that we all grew up with. It's been formatted for viewing on airplanes. You name it, it's been reformatted and moved around. And so there's this huge versionitis problem in Hollywood. That when Netflix makes a deal, sometimes the lineage of the file we're getting from the studio is not really clear what we're getting until we actually crack it open and look at it. And in fact, in this case with Dr. Zhivago, like I said, it was filmed in a nice widescreen aspect ratio, but what was delivered to us was a 4x3 television aspect ratio. And so actually a lot of the experience then was lost for our customers. And the studio acted in good faith and replaced it, and we fixed the problem. But we did accidentally put this up for a little while before we realized the issue. And so what we talk about with the studios is really trying to trace back to the original video DNA of the video here. So we talk about how Netflix really wants to get as close as possible to the original production master. And that's what I call the video DNA. And the native frame rate that the film was shot in, the native aspect ratio that was shot in, pretty much whatever came out of the camera that filmed that movie or that TV show, that's the format that Netflix wants to work in, because that's what we can use to provide the best experience to our customers. And I think that as the studios start to ramp up to the opportunity of working with digital customers like Netflix, there's a big opportunity to use perhaps AWS to build out these digital vaults. And the kind of digital vault that Netflix is building for our own Netflix original productions is something like this, where we've got the original sort of video master. And then before we actually think about formatting it for delivery to Netflix, or perhaps in the future to some of these other use cases here, we conform the secondary assets like the English audio, the Spanish audio, perhaps a dubbed Spanish audio track, the English closed captions, or perhaps the Mandarin subtitles. And we want to conform all those secondary assets to that one sort of true video master. And then delivery to Netflix or our competitors like Hulu or Amazon Prime, is that much easier to do. You just sort of, based on that original master, make the copy you need for that particular customer. And studios can use this for their own digital initiatives like Ultraviolet and Blu-ray. And so we've been talking to the studios about this. The studios are able to create opportunities for themselves for more licensing sales if they could do this. So I'll tell you a story from our recent Nordic launch. We launched the 4 Nordic countries in October of this year. In August of this year, our buying team, the content buyers for Netflix, came to my team and said that they had not yet allocated all of the licensing dollars that were going to be devoted to licensing content for Netflix in the 4 Nordic countries. But the time allotted between mid-August and mid-October was short, only about 8 weeks. And they wanted to know from my team which studios are the most able to deliver reliably, on time, and with a low error rate ahead of launch. And that's where those additional licensing dollars went. And so it's true today that actually effectiveness at being able to do digital delivery for Netflix drives more sales and more licensing for the studios. And so if the studios have a strategy around building out a vault like this, and many of them do, some of them don't, then we think that there's that much more opportunity to make more licensing money from Netflix and also from the growing list of competitors that Netflix has. And I actually think that there's some interesting opportunities to do this within AWS. I priced out here using Glacier. Glacier, I think, list price on the AWS website is $0.01 per gig per month. If you take an 80 megabit video file, 80 megabits per second, 1 hour of 80 megabits per second video is 35 gigabytes. That's 35 cents an hour per month, or $4.22 an hour per year. So it would cost you $4 a year, basically, to vault an hour of HD video using Glacier. And when I talk to studios sometimes about their vaulting efforts, one thing I hear is that disk is expensive. There's still a very big investment in tape. And I think, though, with innovations like Glacier and providers like Amazon, that distinction will start to fall away. I think disk is already cheaper than tape and a lot easier to work with. And I think this is one example of that. So some concluding thoughts. And then there's actually quite a bit of time, so I'm happy to take questions until we run out of questions or run out of time. If this is one of the few times in my career where I can say that, like, if I had to go back 4 years and do something again, that I wouldn't do it really very different. Like, if we could go back to 2008, if we had a time machine like Michael J. Fox did in Back to the Future, and we set the clock back to 2008, we would do pretty much the same thing, knowing what we know now. And when I talk to IT managers sometimes about the cloud and our efforts in the cloud, oftentimes they'll do a very superficial cost comparison, where you say, oh, well, you look at the cost of maybe a C1 medium and what the clock runs at in that instance, and how much storage it has, and how much memory it has, and then they say, okay, well, gosh, I can build you a box that would cost this much, right? And it's, oh, look, maybe it's even a little bit cheaper than Amazon. But that's not really a sort of fully loaded analysis of the cost comparisons between building something like this in the cloud or building it yourself. We don't administer this gear. We don't have any sysadmins working on this system. We don't have anybody that does an SSH into any of these boxes and configures anything on them. We just deploy the machine images using our software and run the system. And it's, there's petabytes of redundant storage and high network traffic, and we haven't built or administered really any of it. And the storage is durable, which is very valuable to us. But the biggest value to us that I have here in red at the bottom is that it has left us in a position that when the opportunistic but very short time frame opportunity happens. So for us, it was the opportunity to be part of the iPad launch, or to be part of the Apple TV launch, or to get some big new content library up quickly. You can't put a price on being able to agree to do that and do it in just a few weeks. Because if we were still building out data centers in the old model, we would not have been able to jump on those opportunities. So that's been the biggest advantage for us, and something that we would do again given the chance. So that's the end of the slides I had, but I'm happy to take questions, and we've still got about